Okay, in this video we're going to be looking at how to implement the Fibonacci numbers in Java. So what are the Fibonacci numbers? Well, I've got them right here. So all they are is, and this is called the zero index. This sometimes isn't included, but I'm going to include it here because I think it helps conceptually with the understanding. Fibonacci numbers are just, the first one is 1, the second one is 1, and then every number afterwards is the sum of the previous two numbers in the sequence. So 1 is the sum of 0 and 1. 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 3 is 5. 5 plus 8 is 13. 21 plus 34 is 55. So every number is just the sum of the previous two in the sequence. Awesome. So let's write a simple program to implement that in Java. I'll put it in a separate function and I'll make it return an integer. Let's just call it fib, and I want to return a certain index, Fibonacci index. So how are we going to do this? Well, the way I want to do it is I want to first establish some preconditions. Obviously, if index is negative, it won't work. You can't have a negative number index. So what I'll do there is I'll just print out a message saying it's invalid. Return 0. What if our index is 0? Well, the 0th Fibonacci number is 0, so we can just return 0. Simple as that. Now here's where it gets a bit more interesting. Fibonacci number 1 and 2 are both 1. They're both 1. So how is this function going to know how to calculate each number? Well, if it knows what the first couple are, it'll be able to calculate for the rest of them if we just give it the formula, right? So if my index is 1 or 2, we'll just return 1. And this is almost all the information it needs to calculate any of the numbers. Now, let's say we want to return Fibonacci of 3. Well, it knows what 1 and 2 is, so all it needs is the following. And why is this going to work? Because it knows that the first one is 1, it knows the second one is 1, and so it's going to know what every other one is if we just tell it to return the sum of the previous two. That's the previous one, and that's 2 before in the sequence. So what's going to happen in this function if we say get the number 5 here? Well, it's not less than 0. It's not less than 0, so it's not going to go here. It's not 0, so it's going to skip this, and it's not 1 or 2, so it's going to skip this. It's 5, so it's going to go here, and it's going to return Fibonacci of 4 plus Fibonacci of 3. So the function is going to calculate Fibonacci of 4, Fibonacci of 3, then add them. Let's see if that works. So let's print out the output of that function. Let's try 5. So what happens when we put 5 in? There we go. 5. And sure enough, 5 is the 5th number. Okay, let's try 6. Should get 8 this time. There we go, 8. 7, 8, 9, let's try 9, we should get 34. Awesome. Let's try 10, we should get 21 plus 34, which is 55. Very good. So I wonder what the 100th number is. Actually, let's stop that. Let's try the 20th number. $6,765. Very good. Let's try the 50th. Let's try the 30th. Might be becoming too big to store in integers. Okay, so now we're already in the hundreds of thousands. So you can see once you go beyond this, you're going to get very, very, very big numbers. Okay, we'll just stick with that for now, and I'll explain how to get the bigger numbers in the next video. Thank you for watching.